This is a very simple little extra topic-y thing, but students often don't really understand this and they just memorize a sentence, this sentence, and that's okay, except for what happens if you miss one word of that sentence, then you're not going to get that mark. And if the question is tweaked in any way, then you're going to sound like you don't know what you're talking about. And it's a relatively simple concept, so try to actually understand it rather than just memorizing this. Right, so what we get with a change of argument is we prove that there is a zero of something between 2 points. And the way that we prove it is this. We take a function that we want to be 0. So say, for example, this one. We take a function that we want to be 0. And I'm going to call it, let's call it little f. And we say, what is little f doing at this end of the interval? So we've got an interval on the x-axis, there's a, there's b, and we work out what the function is doing at a. Now it doesn't matter what number it is, but it could be positive or it could be negative. So we write down what it is to 3 significant figures, make sure you do at least 3 significant figures, and then you say whether it's positive or negative. I'll say positive for this one, but if it's negative, say negative. Now that means that the graph of f of x is up here somewhere at a. Then, surprise, surprise, you do f of b. So you're doing at least 3 significant figures for that number. And what you're going to find is that it's going to come out negative or positive. If that was negative, there's going to be a change of sign. Now we have to explain to the reader what it is that this means. Now, obviously, what it means is that if the graph goes from there to down there, then at some point it crosses the x-axis, and that's the root. That's the 0 that we are looking for there between A and B. But how do you write that mathematically? You need to say 2 things. You need to say that your function is continuous. And what that means is that you draw it without taking your pen off. So think, for example, about the graph of tan x. Tan x goes from all the way down here and then it goes up like that, a bit like x cubed, but then it jumps back down again. So if I was doing this x value here, that would come out positive, and this x value here, that would come out negative. So I would get my change of sign, but that graph does not cross the x-axis between those 2 points. It goes off to infinity, kind of comes around the back of infinity and comes back up the other side. So it's no good just to say there's a change of sign. You also need to say that your function is continuous and changes sign on the interval AB. And the notation we use, it looks a bit like a coordinate, but it's not. It's an interval, and from the context, you'd know that means going from A to B rather than the 2-dimensional coordinate A to B. AB. Right. There are other things we could find, though, other than zeros, even though what this change of sign argument does is it finds a root, it finds a 0. So how can I use it to find this point here, which is not the 0 of the function? Well, it's okay because it's the 0 of the gradient of the function. So at this point here, the gradient of the function is 0. So I wouldn't have f here, I'd have its derivative. And I wouldn't have f here, I'd have its derivative. And I wouldn't say f of x here, I'd say f primed of x is continuous and changes sign on the interval. And then your final sentence, your final little bit, therefore, this was the whole point, this is what we wanted to prove, therefore f of x equals 0 has a root on the interval AB. Now, here's the important bit. If we were doing this, if we were doing a turning point of f, not a root of f, then you need to get the end of this sentence right. If you say, therefore, f of x is 0 has a root, you're talking rubbish, it doesn't have a root. And if you even say f primed of x has a root, that is true, f primed of x does has a root, but what you were asked to find was a turning point of f. So what you would need to say is the derivative at A is positive, the derivative at B is negative, the derivative is continuous and changes sign on the interval, therefore f of x has a turning point on AB because f prime of x has a root. So you really do need to, you can't just write, the number of exam papers I've marked where people do this, and then write change of sign root. change of sign root, not even a comma, change of sign root, like one continuous stream. That is not, change of sign root is not going to get you that mark. I'm not going to give you that mark, and nor is any other examiner. You need to properly explain what's going on. Now, let's think about it the other way around. Oh, there's one other example, which is where I might be finding out where two graphs cross. Now, in this case, it's f of x minus g of x that we want to be 0. So f of a minus g of a is positive. F of b minus g of b is negative. F of x minus g of x is continuous and changes sign on the interval AB. Therefore, f of x equals g of x on the interval AB, explaining what it is you found, and what you found is what you were asked to find. Okay, thinking about it the other way around, let's say we don't get a change of sign. Does that mean there isn't a root? So we go to A, we go to B, they're both positive, it doesn't change sign, therefore there's no root. That's not true. We could have loads of roots, look. Whoop, loads and loads of roots. So if you understand what that change of sign and continuity tells you about the graph, then it's pretty easy to make interpretations. Okay, sketching 2 to the x minus 3 and ln x on the same graph, so we're going to have this situation of things crossing by the looks of things. Okay, so ln x has got an asymptote here at x is 0. It comes up, it goes through 1 and it goes off that, and it does not go horizontal. The graph of 2 to the x goes like this, and then it's been moved up 3, so it's now got an asymptote here. Oh no, it hasn't, it's been moved down 3, excuse me, that's a minus 3. So let's just get rid of that asymptote and put the asymptote down here, minus 3. Okay, when x is 0, this is 1, so it goes through minus 2. It's coming up along its asymptote, and then it's going up, and I don't know where it's going to cross. Let's see. This is 1. What happens when I put a 1 in here? 2 minus 3 is negative, so it's still negative at that stage. So it's going like that. And this one doesn't go horizontal, but they will cross somewhere over there. Right. So there's the two graphs. How many solutions does the equation have where we put this equal to this and then set that equal to 0? So 2 to the x minus 3 equals ln x. That's the same as saying ln x minus 2 to the x plus 3 is 0. And this graph crosses this graph twice. So y equals 2 to the x minus 3 crosses y equals ln x twice. So f of x, which is one minus the other, has two roots, two solutions. One of them is a bit less than 1, and the other one is really quite big. So 2.2 we're going to start with. So I'm guessing we're going to... Oh, there's a root between 1.8 and 2.2. Okay, so, oh, this one must be not that big then. It can't be that one because that's smaller than 1. So it must be this one, and this must be along here somewhere. Just before it, 1.8, and just after it, 2.2. So that's the interval we're looking at. Okay, so we do f of a, but it's not going to be f, it's going to be 1 minus the other. So it's going to be ln x. Oh, it is f in this case, isn't it? Because we redefined. Okay, so f of 1.8 is going to be ln 1.8 minus 2 to the 1.8 plus 3. And at the other end of the scale, we've got 2.2. So this is ln 2.2 minus 2 to the 2.2 plus 3. And when you do this, make sure that you make it very clear what you're subbing in. Don't just write f of 1.8 is, yes, low batteries, I know. Actually write down what you're subbing in, because then I can give you marks. I can't just give you marks if you just write numbers down, because I don't know what you're doing. Plus 3. So this comes out to be 0.106 to 3 significant figures. And if I go back into that function and just change it to a 2.2, yes, negative 0.806 to 3 significant figures. So what have we got? We've got not f of x. Oh, yes, okay, I shouldn't have used f here. This function here, f of x, is continuous and changes sign on the interval 1.8 to 2.2. So f of x has a root on this interval. And the other way that we could describe it is that the graphs of y equals 2 to the x minus 3 and y equals ln x cross between these two values. Now, does that mean that we know what the root is to even one decimal place? No. It could be 1.8, it could be 1.9, it could be 2, it could be 2.1, it could be 2.2. I don't even know whether... Oh, no, I do know, look. To one significant figure, the root is 2, because this rounds to 2 and this rounds to 2. Let's say I wanted to know what it was to one decimal place. So if you create a number line, and I'm just going to guess now because I can't be bothered to do continued iteration on this, but let's say that we think, that's not very in the middle, is it? That's the middle. We think that the root is going to be 2.14 to 2 decimal places. Now that means it's not 2.15 and it's not 2.13. And it means that it's somewhere between here and here. It's somewhere in there because everything in there rounds to 2.14. Everything. So what you need to do is a change of sign argument on this interval. That one there, that number is 2.135. And I know most of my students can do this without drawing this number line, but I can't. I always get the 5 in the wrong place. And this is 2.145. So what you would do is a change of sign argument between here and here. And then not only would you be able to make all of this conclusion here, you would also be able to say, therefore, not only do I know where the root lies, I know because that was small enough, that interval, that the root is 2.14 to 2 decimal places, 100% definitely. So there's that extra bit on the end that you might be able to come up with based on how small your interval is.